Created by Lord Kelvin in 1867. The Kelvin water dropper is an electrostatic generator, a device capable of producing electricity at high voltage and low current. Since the setup requires a very small spark gap, which is separate from the water source and the current produced is not very harmful, the setup is generally regarded as not being very hazardous. By utilizing the ionic nature of tap water, which often contains other ionic minerals as opposed to highly purified or distilled water, which is dielectric, the Kelvin water dropper manages to create a potential difference, which is what causes the spark in the first place. We may assume that there's an imbalance of charge in the water, causing an excess number of cations in the water to flow through the inductor to the left. Hence, the free electrons in the metal inductor will attract the cations, causing the left inductor to become positively charged, and the water to become negatively charged due to the positive charges in the water being repelled. The water then falls into the left metal container, causing the container to become negatively charged. Since the container is connected to the right inductor becomes negatively charged as well. The right inductor would then induce a positive charge in the water flowing through it due to like charges, again in this case negative, repelling. The water thus charges the right container positively, and connecting the right container to the left inductor, we've created a self-amplifying loop. The entirety of this setup can be further explained using Faraday's law, however to prevent the explanation from getting even more convoluted and lengthier, I'll save that explanation for the very end as an appendix. Should the setup work successfully, we should hear the rate of water flow slow down to a halt due to the self-amplification system of the setup, which at the moment water flow ceases will cause a spark to happen. Next up, we'll be taking a look at the setup that I made. The first component worth looking at is the water reservoir. I got lucky and managed to find one large container, however it is possible to carry out the experiment with two smaller containers as well. You do have to use a strip of aluminum foil or any other conductive material to make sure that both the containers are connected. One can think of the water reservoir as a battery of the setup itself, so the two being disconnected would be akin to a battery with a separate anode and cathode. Next up is the inductor. Now, if you live in a time and place where there isn't a global pandemic ravaging the world, you could probably acquire one of these online or from your local university. I unfortunately didn't have that luxury, and for better or worse, went through the process of making my own inductors. Conceptually, the inductor is rather straightforward. It's a metal toroid with a bunch of copper wire wound around it. The issue, however, is that I didn't have bare copper wire lying around. Usually copper wire comes with a layer of insulated coating, which needs to be scraped off if you want to put it to use for these kinds of purposes. So after settling for a tin can as opposed to a typical toroid and scraping the protective coating off the copper wire to the best of my ability, I put the inductors to use into my setup to find that absolutely nothing was happening. After doing a bit more research regarding tin cans, I realized that they had a protective coating on the inside of them to prevent the tin from dissolving into the contents of whatever food they're supposed to be containing. So, more scraping ensued, and the coating was removed, and then nothing. At this point, I just got really tired of the whole affair and decided that I'm going to wrap the whole tin can in aluminum foil and skip the copper wire. And then, it actually worked. The charge containers were probably the easiest part of the setup to fix up. I didn't have any metal containers, so I opted for two empty yogurt buckets and decided to line the inside with aluminum foil, and that was about as complicated as it needed to be. The wires were connected in a similar crosswise manner that I had detailed in the beginning of the video, so the diagram was my guide there. The spark gap had to be built separate because the entire setup is quite sensitive to moisture. If you happen to be working with a setup in a location as glamorous as a bathroom, which is where I set up my Kelvin water dropper, you'll find that moisture may become an issue and all the sparks will cease after letting the experiment run for too long. This is affected by the number of people in the room as well, so do be wary of that. Nevertheless, letting the setup sit by itself for about half an hour to 45 minutes would fix up that issue as well and allow the sparks to happen again. As for the construction of the spark gap, well, many other YouTube videos use doorknobs or other spherical metal surfaces. I opted for a more minimalistic design and constructed mine using copper wire, which I had placed approximately a millimeter or so apart. It goes without saying that the larger the spark gap is, the more time it will take until a spark happens. The video that I recorded of the setup was unfortunately horribly squished up by the video editing software due to the fact that I made the cardinal sin of recording in portrait mode as opposed to landscape. Truly an unforgivable act. Nevertheless, now that the setup was up and running, I wanted to test to see if I could increase the capabilities of the Kelvin water dropper by making the water more ionic. In simpler terms, that means adding salt. I hypothesized that if the salt were to be added, the frequency of sparks would increase. After a good chunk of time was spent recording the period between sparks, gradually increasing the moles of salt in the water with each trial, I managed to find an answer. Hence, without further ado, look at this graph! What I found to be rather intriguing was the fact that as I added more moles of salt, the period decreases exponentially. I hypothesized that this is potentially due to the inductance of the inductor that I had made. If my inductor was of higher quality, it could likely have done a better job of becoming charged, and thus we'd see a more linear trend. Nevertheless, we have a graph, so with a bit of quick math, through linearizing the data, we can determine the properties, which are to establish a relationship between how the moles of salt affect the period between the sparks. As can be seen, the exponent of n is negative, which does confirm the hypothesis. However, it is incredibly small. This goes on to show us that there's no way for us to be able to take the Kelvin water dropper and turn it into a portable source of infinite energy, which, if you were expecting that outcome, I'm not sure what to tell you. If an undergrad student could have solved the world's energy concerns with some recycled materials and plywood, I believe they already would have in 1867. Nevertheless, this was an interesting experiment, and I hope you guys managed to learn something about the Kelvin water dropper.